I told you last time that we'd be using Venn diagrams quite a bit, and this section sort of proves that point. Most of it deals with problems where Venn diagrams are the best approach to solution. In particular, we'll be using Venn diagrams to count certain things. It's really important to get your mind thinking about these things in the right way, and I think it's very helpful if you can do so. So I thought I would try an interactive exercise to see if we can get our brains thinking about this stuff in the right way. If it works, I think it'll really make some of the exercises that might be similar to what you'll see in your homework a lot easier. So let's just jump into it. Raise your hand if you like spaghetti. Hold them up high so I can get a good count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Raise your hand if you like grits. Raise them high. 1, 2, 3, 4, 5. Finally, raise your hand if you raised your hand at least once during this exercise. Hold them high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so let's see if we can make some sense of these numbers. If you can make sense of these numbers, I think you will be getting your thought process the way you need it to be for the Venn diagram exercises that you'll see, for instance, in your homework. So let's see if we can come to grips with this number, this set of numbers. And to do so, I want to display the Venn diagram that could describe this. I have a circle S for the spaghetti lovers. I have a circle G for the grits lovers. And if you just look at it, just face on, you might say, well, 17 for spaghetti, 5 for grits. So what about 17 in the spaghetti circle, 5 in the grits circle? Any comment about that? Does that look right? What do you think? Exactly. We're not considering the overlap, the people that like spaghetti and grits. Just looking at those numbers, is there a way to figure that out? Just think about it a minute. 17 and 5 is 22, but only 18 of you said that you raised your hands at least once. 18 from 22 is 4. Doesn't that imply that 4 of you liked grits and spaghetti? So that tells me that I should have a 4 in the overlapping region between spaghetti and grits, and that those numbers that I wrote in earlier, 17 and 5, are not right. What I want is for all the numbers together in the spaghetti circle to add to 17. So if I have 4 in the overlapping area, that means I need 17 minus 4. I need 13 more in the part of the spaghetti circle that I had earlier labeled 17. So not 17. I want 13 and 4 to add to 17. Similarly, for the grits circle, I don't want that 5 there because 4 people like grits and spaghetti. I want the grand total in the grits circle to be 5. So 5 minus 4 is 1. There's one person unaccounted for that likes grits but does not like spaghetti. And to see that that sort of all the counting works out, if you take 13 plus 4 plus 1, you get 18, and that matches the number of people who raised their hand and said that they raised their hand at least once during this exercise. So I don't want to do anything else with this exercise. It's just a simple illustration of the sort of thought processes that are going to help you when you get to the real homework problems. A music teacher took a survey of 495 students, and here's the results. I like to have a way of thinking about these things that makes sense to me, and I always think about these as people being in the room raising their hand. So I like to think about that as I've got 495 people in this room, and when one of these questions is asked, they raise their hand and I count. That's how I get these numbers. If you think about it that way, I think everything is easier to process. That's tip one. Have some way of thinking about these numbers, and I think the hand raising is a perfect analogy to this. It makes things work out properly. I've got a second tip. When you're working these Venn diagram problems like this, it's almost like a dartboard. You're trying to go for the middle. If you can possibly start in the middle and complete this thing, you're better off in the middle. It's like throwing a dart. You want to go right to the middle. I have a circle for the rap music lovers, I have a circle for the rock music lovers, I have a circle for the heavy metal lovers, and I allow them to overlap. If I'm really trying to target the very middle, this little wedge shape, those are the people that what? How would you describe those people? Again? They like all three. Do you see that number up there on the screen anywhere? There are 160. I popped up a couple other things as I was talking, so let me address those. It's sort of a series of tips. I've done these things so much I can sort of give you some advice based on all the years of doing these. Tip one is think about it in terms of people raising their hands. I think that really helps. Tip two, try to start in the center if you possibly can. You notice a question popped up. Tip three is don't worry too much about the question until you get the Venn diagram filled out. If you start focusing on trying to answer that question, it's distracting. You don't need to answer the question right away. You have to go ahead and get these numbers in the chart before you start worrying too much about what the actual question was. With rare exceptions. Sometimes they ask such a simple question you don't need to do anything else. But 9 times out of 10, if you start focusing on what the answer to the question is, it just distracts you from what you really have to do, which is get those numbers in there first. So I've already given you 3 tips that seem helpful to me when I'm doing these problems. So, like I said, I want to go to the center. There are 160 people who like all 3 types of music there. And you sort of spiral out. So in this case, I've taken the people that like all 3, so now I kind of want to go to the people that like 2 types. I want to go with people like rap and heavy metal, rock and heavy metal, rap and rock. I want to do all the 2 combinations. So you start off with the 3, people that like all 3, then you go to the people that like all combinations of 2, then you go to 1, and then you go to the people that don't like any of it. So you sort of spiral out from the center, if you want to call that a tip. So I would just say in this case, if you just work from the bottom to the top, that will be spiraling out because they put them in that order. If they don't, you still can find them. But in this case, they sort of in the order, so if you work from bottom to top, it's a natural progression. Maybe they don't always put them in that order, so you can't always say, I'm going to go from bottom to top, but you can always find the 3 and then all the 2s and then go to the 1s, no matter how they actually distribute them. So now I want to look at the people who like rap and heavy metal. Rap and heavy metal. That's this, what I call the football shape, which is the overlap of the rap circle with the heavy metal circle. This is where I think the raising hands analogy comes in nicely. I know that 190 people like rap and heavy metal, so what I'm envisioning, that circle already has 160 in it. So what I'm envisioning is I've got 495 people sitting out here, and 160 of them have already raised their hand. But there are still some people that haven't raised their hand yet. How do I know that? Because it's supposed to add up to 190. So I want the numbers inside that football-shaped region to add up to 190. So 160 people have already raised their hand. There are another 30 people then that have to raise their hand. I know that because 190 minus 160 is 30. So as of now, only 160 people have raised their hand, but I know that there have to be 30 more. Following it? So again, I think that thinking of as people raising their hand is a perfect way to think about it. And then you just keep moving up. There are 245 people who like rock and heavy metal, so you look at the overlap between the rock circle and the heavy metal circle, and again, those same 160 people have already raised their hand. They're very eager people. But we need 245. So that means that there are 85 people who need to get their hand in the air. The 160, they like music a lot, so they're really eager to raise their hand. But these other people need to get their hand in the air, and there are 85 of them. They have to go in that other spot inside the football shape. This is a perfect time to ask a question if it's confusing, because I don't know a better day to answer a question about this sort of stuff than right now. All right, just keep spiraling up then. There are 280 that like rap and rock. Rap and rock is that football shape. It's the football sitting straight up. And we need 280 people with their hands in the air. Right now, only 160 of them have their hands in the air. So there's some people that still need to get their hands in the air, and you find out how many by subtracting. There are 280 people in all. 160 of them have already put their hands in the air. So there are 120 people that need to get their hands in the air. And that goes in the open spot inside of that football shape. And you notice if you add 120, 160, you get the 280 that you need. And you keep going. There are 295 students that like heavy metal. Well, heavy metal has a whole circle for itself. So the heavy metal group is actually that bottom circle. The whole bottom circle consists of the people like heavy metal. And there should be 295 of them, but I bet there aren't already. Here's some people who already have their hands in the air. These 30 people already have their hands in the air. These 160 already have their hands in the air. And these 85 people already have their hands in the air. But I bet you there are some people that haven't raised their hand yet. And I can find out by adding those three numbers up and subtracting from 295. Or, I'll do it both ways to show you. Or you can just take the 295 and start subtracting them one at a time. If you take the 30 people over there on the left that have already raised their hand, subtract it off. Then you take the 160 that have already raised their hand, subtract that off, and then take the 85. Anyway, you can either add the numbers up and subtract from 295 and you'll get 20, or you can just subtract them one at a time. Any way you do it, you end up with 20 students who still need to get their hands in the air. And where does it go? It's got to go in the heavy metal circle. There's only one opening, and that would be there. And if you add up those four numbers, you better get 295. Otherwise, you've made some arithmetic mistake. There's nothing else in the heavy metal circle to work, so I'll just keep moving up. There are 395 students that like rock music. Rock music has its own circle. Same idea. 120 plus 160 plus 85 people have already raised their hands. I'm sure there's some students that haven't raised their hand yet. So to find out how many, you can either add those three numbers up and subtract from 395, or you can just start at 395 and subtract them off one at a time. Either way you do it, you'll end up with 30 people who need to get their hands in the air. And they must be the people over there in that missing spot, those 30 people. Then you do the same thing with rap. 320. You've got three numbers already in there. If you start off with 320 and take away the 120 that have already raised their hand, the 160 in the middle that have raised their hand, and the 30, you're still short 10 students. So those 10 students belong in the missing area there, which I've just now filled in. And if you add up those four numbers inside the wrap circle, you better get 320. There's only one spot that I'm missing a number. Where is it? Somewhere out here. Who are those people? Aren't they the ones that don't like any of those three? How do you find that? Exactly. Just add up all the numbers you have, and whatever's left is what's missing. So Before I've been subtracting one at a time, and I told you you could do it the other way. This time I'll do it the other way. I'll go ahead and add them up and subtract from 495. But you can subtract them one at a time. You can say 495 minus 10, minus 120, minus 30, minus 30, minus 160, minus 85, minus 20. But I decided to do it the other way this time. I'll just add them up first. If you add up 10, 120, 30, 30, 160, 85, and 20, you get 455. And you're supposed to have 495. So if you subtract, you get 40. So there are 40 students, and the only place left for them to go is outside of all three circles, meaning that they don't like rap music, they don't like rock music, they don't like heavy metal. Those are the 40 that don't like any of those three. And if you add up every number in that whole thing, you should get 495. So if you have extra time, you can always double check yourself by re-adding and making sure you didn't make a careless mistake. Notice we still haven't answered the question. But until you get the Venn diagram fully loaded, you really don't need to be looking at what the question is. But now we should be able to look at that question. What do? How many students like exactly 2? That means they like rap and heavy metal but not rock, or they like rock and rap but not heavy metal. Every possibility with 2s. So just start counting them. What about rap and heavy metal? Rap and heavy metal is the overlap between the rap circle and the heavy metal circle, which is here. But they're supposed to like exactly 2. If you count the 160, they like all 3. So you've got to get rid of those 160. Those 160 like everything. You only want the ones that like exactly 2. So inside of that football shape between the rap and heavy metal circle, you only want the outside part, because the inside part are the people that like all 3. So the answer should be 30. And then you do the same thing for the rock rap. The rock rap intersection is this football shape here, the vertical football. And again, you don't want to count the 160, because the 160 people, the 160 students like all 3. And you're not looking for all 3. So that answer would be 120. And then finally, you could see who likes rock and heavy metal. The rock and heavy metal football is that one. But again, you can't count the people that like all 3, because you're only looking for the people that like exactly 2. That means there are 85 people who like rock and heavy metal, but not rap. So if you add up those 3 numbers, you get the answer to the question. 235 students like exactly 2 of the 3 types, but not all 3, and not just 1, and not none. They like exactly 2 of the 3. Now, once you get this set up, I could spend the next 20 minutes asking you questions. I'm not going to do that, but I will ask 2 more questions. How many students like rock music only? In other words, out of those 3 choices, rock is the only one they like. You want it to only be in the rock circle, but no other type. So if you choose one, if you start counting the people in here, they like something else besides rock. If you want it to be just rock, you've got to be in the rock circle, but not inside of any other circle. There are only 30 of them. Like I said, I could ask questions all the rest of the class if I wanted to, but I'll do one more. How many students like only one type? There's only one of those 3 that they like. We've already done the rock. We know there are 30 that only like rock, so you just do the same thing for rap and do the same thing for heavy metal. The people that only like rap, the people that only like heavy metal, we've already done rock. So you get the people in the outer regions of each circle. Those are the people who are in one circle but not in any other circle. And if you add those up, you'll find out that there are 60 students that only like 1. They don't like either of the other 2. So, was that hard? I told you at the beginning that this section was mostly Venn diagrams, and that is true. However, I do want to say there are ways around Venn diagrams in fairly simple situations that might be worth knowing about. You could still do it with Venn diagrams, but maybe something else is better, and that's what I'm going to suggest here. In certain situations, even though Venn diagrams work, you might be better off doing it this way. It's something that your text calls the inclusion-exclusion principle. The idea is simple, and I'll try to make you believe that, but I'll read it first. It says, for all finite sets A and B, do you remember what this notation means? This little n with parentheses, with something inside the parentheses? Anybody remember what that means? I'll give you a hint. It starts with n. What? Did I hear somebody say something? It starts with an n. It ends with r, the first word. It starts with nu, ends in an r. It starts with num and ends in an r. Number. Thank you. That symbol stands for the number of something. So it's the number of things in the union of A and B. So the number of elements in the union of A and B is equal to the number of elements in A plus the number of elements in B minus the number of elements in the intersection of A and B. Think about the spaghetti and the grits. I was asking at one point how many people like spaghetti or grits. You would count the number of people that like spaghetti, then you'd count the number of people that like grits, and we ended up having to subtract because some people liked both. When you say the intersection of two sets, you're counting the overlap. So that's like, if you think of that as spaghetti and grits, you're counting how many people like spaghetti, you're counting how many people like grits, and we realized the number was too big because some people like both, and you have to subtract off the one you counted twice. So you ended up counting the people that like both twice. So that intersection number is just an indication that you counted it twice, so you need to subtract off one of the counts. And that's all the inclusion-exclusion principle says. If you compute the number of elements in the union of two sets, you just need to add up how many elements are in each set, and then you take off the numbers you counted twice. That's all it says. The number of elements in the union of two sets is the number of elements in each set individually added up minus the number of elements that are in common to both. So rather than formally memorizing that, I just remember the words. If you're really good at memorizing formulas, then go for it. But I like to memorize the words. I like to say it to myself. And sometimes you'll find that inclusion-exclusion principle will save you from having to draw a Venn diagram when they're asking about things involving the union of two sets. And I'll show you an example. I'll actually show you probably more than one example, but I'll start off with a really simple example. Suppose I have a Venn diagram with the set A and the set B in it. How many elements are in set A? 8. How'd you get that? Yeah, there's 6 that are in A and not B, and there are 2 more that are in A but also in B. How many elements are in set B? 6, right? Well, 8 and 6 is 14, but obviously that's too big, because if you add 6 and 2 and 4, you only get 12. Well, that's because even though you have 8 in set A and you have 6 in set B, and 8 and 6 is 14, you realize you've counted 2 of them twice, so you have to subtract off one of the double counts. So 8 and 6 is 14 because you've got 8 here and 6 here, but you realize you've counted 2 twice. So you have to subtract off one of those double counts. That's all it says. Simple idea, but it can be useful. Let's try this one. Given the number of elements in set S equals 170, the number in set T 140, and the number in the union of S and T equal 220, find the number of elements in the intersection of S and T. Using the inclusion-exclusion principle, we know that the number of elements in S union T is 220. The number of elements in set S is 170. And the number of elements in set T is 140. If we plug those things in, you see that there's only one unknown, and that is the number of elements in S intersect T, which is what we're trying to solve for. So now it becomes a simple algebra problem. 170 plus 140, of course, is 310. if you move the negative number of elements of S intersect T to the left side of the equation and move the 220 to the right, you'll end up with the number of elements in S intersect T is 310 minus 220, which is 90. Let's try another. If we're given that the number of elements in set A is 1500, the number of elements in set A union B equals 2250, and the number of elements in the intersection of A and B is 310, find the number of elements in set B. Again, we're using the inclusion-exclusion principle, but this time we're looking for the number of elements in set B. So if you plug in everything you know, the number of elements in set B is the only thing you don't know, so that's your unknown. You can leave in the number of elements in set B as your symbol, or you could plug in a variable like X. In any case, 1500 minus 310 is 1190, and if you subtract 1190 from both sides, you'll find out that X is equal to 1060. That is the easiest way to solve this problem. If you wanted to play around with Venn diagrams, you could get the same solution, but I think this is easier. If you did do this with Venn diagrams, you would end up with something like this. I don't really advocate that you do it that way, but you could. Here's another problem where you could use a Venn diagram, but it's much simpler to use the inclusion-exclusion principle. It says a music director wishes to take the band and the choir on a field trip. There are 65 students in the band and 30 students in the choir. The number of students in both the band and choir, in other words, some people are in both, is 16. How many students should the music director plan on taking on the field trip? In other words, the music director needs probably to get a bus to take people, so how many people need to be on a bus is an important number. Well, this has to do with taking band members or choir members, and that's a union. Whenever you say or, you mean union. Whenever you say and, you mean intersection. So we want to count people that are either a band member or a choir member. So the trick is to remember, whenever you're doing an or, that's the same as a union. Well, as soon as you're looking at the union of two sets, you know you can use the inclusion-exclusion principle. So you say, well, I can count how many band and choir people there are. I can count the band people, then I can count the choir people, and then I can subtract off the ones I counted twice. Well, there are 65 band students, 30 choir students, and there were 16 that got counted twice. And so if you subtract 16 from the sum of 65 and 30, you end up with 79. And that tells you have 79 students that you need to plan on taking with you. And again, you could draw Venn diagrams and figure it out, just like we did the grits and spaghetti thing. You could figure it out, but it's just much more straightforward to do it that way. Tired of doing music problems. Let's do something that's got math in it. This time we have a school that has 430 students registered in math, 560 students registered in chemistry, and 225 are taking both. How many students are registered in math or chemistry? In other words, you don't want to count people twice. So this again is an or, which is a union, which kind of lets you know that you might be able to do it with the inclusion-exclusion principle. And again, you could draw Venn diagrams and figure it out if you wanted to. But the inclusion-exclusion principle says to find the number of people that are taking math or chemistry, you count the number of people that are taking math, the number of people taking chemistry, add those up, and then subtract off the intersection, which are the people you've counted twice. So that would be 430 taking math, another 560 taking chemistry. You've counted 225 of them twice, so you end up with 765 unique students. So that's the nice thing about the inclusion-exclusion principle, is it's actually, if it applies, really quicker than trying to figure it out with Venn diagrams. Whereas some of the more complicated problems, that have 3 circles and have all these things going on, you pretty much have to do a Venn diagram. But when it's simple like that and you're just looking at a union problem with 2 sets, think about doing it this way. It just seems to be simpler. I just want to throw in that if the number is a percent, it still works. I don't know if I even need to say that, but I just wanted to throw in that if it works with 17 and 32 and whatever, if I put a percent sign and say 17%, 32%, it still works. So I'm just throwing that out there, that if they put a percent sign on a number, it's still, the principle still works. Here's an example of something like you might see on your homework. It says a blood donation organization reports that about 44% of the U.S. population has the A antigen. Another 15% of the U.S. population has the B antigen, and 4% have both. They even did a pie chart. The question is to estimate the percent of the U.S. population that has the A antigen or the B antigen. That's A union B. Remember, or is union. Union of 2 sets, if you're counting, you can use the inclusion exclusion principle. So that's what I would do. The percent of people that have the A or the B, that's percentage of people having either the A or B antigen, is the percentage of people with the A antigen plus the percentage of people with the B antigen minus the intersection. In other words, the people that have both the A and the B antigen, because you've counted them twice. They tell you that 44% of the population has the A antigen, 15% of the population has the B antigen, and 4% has both the A and B antigen. That means they're an AB type. If you have the A antigen and the B antigen, you're an AB. And if you calculate that, that's 55. Now, I'm a big proponent, especially on a test, of having a second way to check your answer. Because they gave you the pie chart, you could check your answer by doing it in the pie chart and see if you get the same thing. So we're trying to count the people that have either A or B or both. So if you just look at that, this 1% has the A and the B. That's A or B, and that's A or B or both. The AB positives have A or B. They actually have both. The B has a B. There's a B positive, B negative. There's an A positive and A negative. And if I counted B positive, B, I think so. If you add up those numbers I circled, you should get 55 unless I skipped one. So if you take 34 plus 6, that's 40. That's 42. That's 45. That's 46. What have I missed? Oh, I didn't count the B plus. 46 plus 9 is 55. In this problem, we're given a Venn diagram with circles A, B, and C. And we're told that the number of elements in set A is 29, the number of elements in set B is 33, the number of elements in set C is 38, the number of elements in A intersect B is 16, and the number of elements in the universal set is 78, and they want us to find those numbers R sub 1 through R sub 5 in the Venn diagram. Notice they've given you a lot of the information in the middle part of these. When we're starting from scratch on these, we typically go for the dead center, so that value of that where there are 3 elements. Generally, we would start there, but they've already given it to us. Looking back, the most specific information that they actually gave us was the fact that the number of elements in A intersect B is 16, and that represents what I typically call a football shape. It's the intersection of set A with set B. That's supposed to be 16, but there are already 3 elements in there. So if you do a little algebra, you'll find out that the number of elements in the region represented by R sub 2 must be 13, because 13 plus 3 is 16. Once you get that, you notice that you know every value inside of circle A except for R sub 1, and you know from above that the number of elements in set A is 29. So you can use that fact to add up all the elements in set A and figure out what R sub 1 must be. It turns out that 13 plus 3 plus 7 is 23. So R sub 1, the number of elements in that region R sub 1, must be 6. And you keep doing that. Now you go to circle B and you see that those numbers have to add up to 33, meaning that R sub 3 must be 12. And finally, circle C, and you add up all the numbers in circle C, and you figure out that the number of elements in the region R4 has to be 23. And finally, you know that there are 78 elements in the universal set, so if you add up every number in the rectangle, that has to come out to be 78, and if you do the arithmetic, you'll find out that the number of elements in that R sub 5 region must be 9. A survey of 1,800 teens showed that 1,150 read Marvel comics, 680 read DC comics, and 130 do not read either Marvel or DC comics. The first question is, how many teens read both DC and Marvel? The first thing I would notice is they told us how many don't read either, but if you're thinking back to the inclusion-exclusion principle, you're going to need to know the union and intersection of those, not how many don't read either. So I would think about that this way. If 1,800 teens are in the whole group and 130 don't read either Marvel or DC, that means the rest of them, 1,800 minus 130, which is 1,670, do read either Marvel or DC. Now, the reason I thought of it that way is I know that the inclusion-exclusion principle needs that value, DC, union, Marvel, and OR is union, remember. So now I can just plug in. If 1,670 teens do read either Marvel or PC, then that goes in on the left side of the equal sign. I know that 680 from above read DC, and I know that 1,150 read Marvel, and you'll find out the number of teens that read DC and Marvel, that's DC intersect Marvel, is 1,830 minus 1,670, which is 160. Second question, how many teens read only Marvel? It might be better to put this back in a Venn diagram if you're having trouble thinking about it sort of abstractly. I do know that that 160 that I just found in part A is the intersection of DC with M. Now they're asking how many teens read only Marvel. Well, I know from above that 1,150 read Marvel. That means the two numbers inside the Marvel circle have to add up to 1,150. So all I have to do is subtract 160 from 1,150 and I'll find out that 990 teens read only Marvel.
A survey was completed by individuals who are currently on the Zone diet using a capital Z, the South Beach diet using a capital S, or the Weight Watchers diet, capital W. All persons surveyed were also asked whether they were currently in an exercise program, capital E, taking diet pills, capital P, or under medical supervision, capital M, and they made a table of this. In my opinion, there are actually two ways to do this, but if it were me, I would do it the way where I don't need those totals there. I'll tell you in a minute that you can make use of those totals, but to me they're distracting and I'm just going to cover them up. There is a way to make use of them, but I want to do it just straight on. Let's answer these questions. S intersect E. S is South Beach diet, E is an exercise program, and an intersection means and. So we're looking for the people on the South Beach diet and an exercise program. So South Beach diet is the middle row, exercise routine is the first column, and intersection or and means the overlap. So what do you think the answer is? 106. Now let's zoom a little bit. Zoom is zone diet, union, medical supervision. But it's not intersection, it's union. Union means if you're in either one, you get counted. So the zone diet people are on the first row. The medical supervised people are on the third column. If you were looking for intersection, the answer would be 61. But we're not looking for intersection, we're looking for union. Union just means count them all. So you count all those numbers up and add them up. 122 plus 84 plus 61 plus 51 plus 49. So there are 367 people who are either on the zone diet or are under medical supervision. If it were intersection, the answer would be 61, but it's not. C is the complement of S intersected with the union of E and P. I want to union E and P and then intersect that with the complement of S. Parentheses are a grouping symbol, so you probably want to start with the grouping first. E or P just means the first column numbers and the second column. I put them all in one big, I hesitate to call that a circle, but whatever you want to call it. You could just make them two separate ones too. It doesn't matter. I just made it in one big one, but you could think of it as two separate ones. Either way you want to look at it. That's E or P. Now I want to find S complement. Well, S complement is everything but S. S is this row right here. But I want everything but S. So instead of circling the S row, I circle everything but the S row. So I circle the Z row and the W row. That's S complement. S is the middle row. S complement is everything but the middle row. And what operation am I trying to do between the verticals and the horizontals? The operation is intersection. Intersection means overlap. What numbers overlap the horizontals with the verticals? There's one of the overlap numbers. There's 1, 84, 122, 84, 139, 48. Those four numbers are in the intersection of the verticals with the horizontals. Add them up and you get 393. How about this one? Z union S intersected with the complement of M. So union means everything. So when you're doing Z union S, those are rows. It's just those first two rows. You could make them two separate ones. It doesn't really matter, just so you get them all circled. That's Z union S. Then you want to look at M complement. M complement is everything but the M column. M is a column, so M complement is every column except the M column. That would be E and P. And again, I just put one big circle around it. If you wanted to break those up into two separate ones, you could. It's not, doesn't matter. In any case, we're looking for the intersection of those two things. So intersection again is overlap. So this time the overlap of the horizontals with the verticals is the 122, the 84, the 106, and the 66. And if you add those numbers up, you get 378. How about W complement intersected with the complement of P union M? Again, I tend to start with the stuff in the parentheses first. So let's forget about the complement right now. Let's tackle P union M. Well, P union M is these last two columns. But I don't want the last two columns. I want the complement of the last two columns. In other words, I want everything but the last two columns. So what I actually want is column E. Everything but P union M. P union M are the last two columns, so P union M complement is everything but the last two columns, which is just the first column. That's P union M. What's W complement? Everything but W. W is a row, so it's everything but row W. Everything but row W would be rows Z and row S. And we're doing intersection again, so we're looking for overlap. There are only two numbers that overlap in that region. That's the 122 and the 106. So there are 228 that were on those diet conditions that were mentioned by that statement. And last but not least, W complement union P. So W complement is everything but W. That would be the S row or the Z row. And P is the middle column, but this time it's union. You've got to pay attention to the symbol. It's not intersection. If it were intersection, it'd be 84 plus 66. But since it's union, you just count everything that gets circled anywhere. Anything that gets circled gets counted. So even the 48 gets counted, and the 61, the 51, everything that got circled anywhere is in the union. You add them up, and you get 538. And the last thing I want to say about this is I covered up the totals because I wanted to do it this way. I think what they intended you to do is keep the totals in there and use the inclusion-exclusion principle. If you put the totals back in there, when you get a whole row and you want to add them up, the total is already there. And you could add up a whole column and you'd have a total there, and then you could use the inclusion-exclusion principle to subtract off the overlap, and you could get totals faster. I've found that the totals are more confusing, so I don't do it that way, but I actually think they intended for you to use the inclusion-exclusion principle and actually use those totals. You'd add up a row number and a column total, and then you'd subtract off the overlap, and it would give you the answer faster. It keeps you from adding up a whole bunch of numbers like that, but I found out just by experience that people make more mistakes with the total columns in there than they do if they're not. So I tend to take them out and just add more individual numbers. But that's up to you. If you're really interested in this, try doing it with the inclusion-exclusion principle and leave those totals in there. And you can do it that way. You'll get the same answer.